He kōna ipurangi tēnei nā te reo irirangi o Aotearoa.
They say life is stranger than fiction.
They got water, methane, ammonia and hydrogen. They put that in a container, sealed it, with nothing else in there. They hit that with electricity and they cracked it all open and had a look in there and they found 20 different amino acids.
But sometimes what we see in movies or read in books is so incredible that it obviously couldn't be possible. Or could it?
But then after 75 bounces, it releases all this energy.
Yeah, and it doesn't take much.
No. And so then it goes back to, does Flubber have infinite energy?
Hi, I'm Brian Crump and you're listening to Sci-fi Sci-Fact, a podcast where MacDiarmid Institute scientists fact-check popular science fiction. On this episode, Dr. Nathaniel Davis, MacDiarmid Institute Associate Investigator and a lecturer in physical chemistry at Victoria University of Wellington, takes us on a blunder through Flubber, which looks like silly putty, but defies the laws of physics.
Little touch of electricity. Wow, what a bang.
Yeah, little touch of electricity.
It's not helpful. Oh boy, this is not good.
No, sir.
Weebo,
What?
get a broom.
That'll help.
So I've summed it up as something which looks a little bit like silly putty, but behaves like plutonium without the radioactivity.
Yeah, pretty much. It's actually, they based it on the silly putty was the original sort of thing. They made the Flubber as part of a marketing campaign after the movie.
Really?
Well, the original movie, it was the absent-minded professor in 1961, and then they went on to make what they called Flubber, and that evolved into silly putty that we have now.
Okay, so this was actually a remake of The Absent-Minded Professor,
Yes,
which
yes.
I can't remember who starred in that version in the 60s, but they decided to call it Flubber because that would be good for marketing.
Yeah, I think so, yeah.
Well, that's Disney for you.
Exactly.
They're pretty good on the old merchandise. But is it possible to have something that is like silly putty, but then if a little bit is added if you smear Flubber, for example, there was a scene I was watching and Robin Williams, the mad professor, is smearing a golf ball with Flubber, and then suddenly the golf ball is shooting around like nobody's business, like a bit of sodium on water. Is that actually possible?
So it depends. So Flubber has a lot of different properties, and one of them being it bounces. And it bounces very sort of strongly, so much so that it's meant to bounce more or higher than you drop it from. So normal things bounce, it then goes up lower and lower, lower. Flubber has the opposite. Every time it bounces higher.
Okay.
And I've got a couple of notes on that later,
Yes,
but
yes.
talking about the golf ball, what he does, he grinds up the Flubber into a sort of a gluey sort of powder cream and rubs that on a golf ball. So if you have a material that is inherently bouncy, you can coat another ball with it. So if you got a golf ball, you wrap that in rubber, it can bounce more. If Flubber exists and bounces higher than it's dropped from, and you wrap that around a golf ball, that would work. It's just whether Flubber itself works.
Can anything? I thought a law of physics was that if something bounces, friction is going to take some of the energy. When it contacts with the ground, bang, there's friction, and that's the loss of energy. So it's not possible.
Yep, that's absolutely correct.
For something to bounce higher.
Unless there's
second
two ways
time.
it can do it. One is it has some form of internal energy that it's releasing. So it's kind of like a battery. When it bounces, it releases a bit of energy and it bounces higher. And that would only work for as long as it has energy left, and then it'll just bounce like nothing. Or it's somehow absorbing energy on each bounce. So when it hits the ground, instead of losing that energy, it's taking energy maybe in the form of heat from the ground. So each time it bounces, it might cool the ground down.
Right. Is there any evidence in the movie to support
There's some
hypothesis?
So every time they open the flubber from its little pressurized container, that's cold. So it goes in warm, and every time they open it up, it's frozen. You see frost. So I've sort of had the idea that maybe the idea of the internal energy breaks apart really quickly because the amount of energy needed to exponentially bounce, it's exponential. So it's infinite energy, and you can't store that. So if it's taking energy and cooling things down, that's a possibility. But again, because it's exponential, the reason why we can't have things that bounce infinitely is because it just blows out of proportion. So we did a quick calculation that if we have 100 grams of flubber and we drop it from a meter high.
Around a ball?
Oh, no, just flubber
just
by
the
itself.
flubber.
Yeah.
Just
Drop
flubber on its own.
Yep, a meter high, drop it onto a 10 by 10 centimeter slab of concrete, about 1 centimeter thick. And the idea is every time it bounces 10% higher. So first bounce is a meter, 1.1 meters, and so on. And the only assumption we make that all the energy that's needed to increase that bounce comes from heat from that concrete tile. So you get the specific heat capacity of the concrete tile. You can work out how much energy you need to bounce higher. And what we worked out is after 10 bounces, you're at 2.6 meters and you've lost 1 degree of heat. After 50, you've lost 25 degrees of heat and you're at 117 meters. But then after 75 bounces, although you're over 1 kilometer high, your piece of tile now is at absolute zero. So
And that means there's no more energy to take from it.
So the next bounce has to be a regular bounce that doesn't break the laws of physics or doesn't take energy in. So it gets complicated because like how far can it absorb energy from? Can it take energy from a meter?
Yes. What if it can take energy from the whole planet Earth?
Then it's terrifying because you have something that every time it hits or collides with something takes more energy than it had and goes off in the opposite direction. So it's going to be bouncing around the universe, taking all the energy and never stopping until there's no energy left.
Would it get to a point where it would be going so high and at such a velocity it would escape from the Earth anyway, and then the Earth would keep the remaining energy that hadn't been taken out of the flubber or by the flubber?
Yep, so that could happen, but then the flubber's still either in orbit hitting things and taking that energy or off on some course throughout the universe until it hits something else.
I mean, if something like this existed, the universe would be like a Dodgems course.
Yeah, it'd be like flubber's coming, let's move the planet a couple of degrees because otherwise we're gone.
Right then, so that seems to rule out that as a possibility. Is there any material, however, that does this in any way, even just absorbing a bit of heat and therefore bouncing more than you would expect it
Not
to?
really. The idea of absorbing heat from contact in you need a chemical reaction that when you compress your material, the chemical reaction happens and then that takes energy. So that always needs precursors. So you'd run out of the material that's reacting quite quickly, that's taking the energy. There are things that you press on them and they do make a electric potential. So a piezoelectric crystal, you press on the crystal and it makes a spark. I think it's the sparks you use in ovens or oven lighters. It's a little
really?
crystal.
Is that what it is?
Yeah, so you press the crystal with a bit of force and it makes a voltage potential which sparks. So maybe that sort of works because it's like a bouncy thing, but they're all really rigid crystals and you move the crystal lattice. The idea that a flexible polymer can also have this is sort of not realistic.
I'm sorry for going off on a tangent here, Nate, but when did we discover that crystals had this ability to create a charge? If you put force on them?
I'm not sure exactly on the year, but it's been known enough that there's applications for years. So like the old lighters we had were piezoelectric spark crystals. So I'd say
Really?
at least
Really
sort of
cigarette
50
lighters?
years. Yeah, cigarette lighters can have them in them. Not the ones that had the flint.
Yeah, because
the
I thought
ones-
that was just friction doing
Yeah,
that.
so there's friction ones or there's just crystal pressing. The interesting thing is what you can do, the way ultrasound works is the opposite. You put in electric current into the crystal and that causes the crystal to change its shape. So then you put in a really fast electrical current and the crystal vibrates really quickly, producing the ultrasound we use. So at least as long as ultrasound has existed.
Really?
It's a
Ultrasound,
piezoelectric
so
effect.
that we use to scan
babies and stuff.
inside, find the baby and that kind of stuff?
Yeah.
Wow. And what kind of crystal? What element
This
do you know?
is going further into
Sorry,
the research for inorganic
I
waste.
don't know
but
if your colleagues at the Diamond Institute warned you about my tendency to go off on a tangent.
I wouldn't know, but they're normally some form of mixed oxide, I think, or alloy. I wouldn't know much about them. I know that you
Okay.
can make them.
Anyway, fascinating. But sorry, I'll bring us
So
back to the flubber.
my second year chemistry teacher isn't listening from Sydney because he'll be right on it.
Does flubber do anything else that's remarkable?
Yeah, so it does a couple things. The one thing it does first is like it looks like it's alive. I only saw the trailer. At one stage, it looks like a little amoeba amorphous body, but it also then looks a bit like a fat human shape, and it dances and plays music during the film.
Right.
And so I had a bit of problem trying to work at the materials aspect of that. But the way they make it does do some hints. So one of the big things they make is a lot of the way they make it is just pop culture of science. Like it looks cool. A lot of flasks bubbling and colors and smoke.
Yes.
But one of the key ingredients is there's definitely solutions of different things. There's gases because it's bubbling, and there's electricity. When they make it, they zap it with enough electricity to cause sparks in the show. And the way they actually made life, or they think life was made, is back in the prehistoric Earth, there was lightning, there was gas, there was water, and the idea of given enough lightning, gas, and water time, you can make life and organic molecules.
Amino acids.
Yeah, and so the amino acids comes from the famous Miller-Urey experiment, where in 1952 they got water, methane, ammonia, and hydrogen, which is what they thought existed back in the prehistoric Earth. They put that in a container, sealed it, and they allowed the water to evaporate. They hit that with electricity, with all the gases there, and then they allow that to condense like it's raining. And they just do that thousands and thousands of times, and with nothing else in there, the solution slowly goes from like clear to a pinky to a red to this dark black color. And they cracked it all open and had a look in there. And they found 20 different amino acids from synthesis of amino acids from nothing. And so in Flubber, he takes all the stuff that was needed, what we think may be able to create the building blocks of life. He also throws in hair as an organic catalyst. So he's already put in some DNA and some cellular material there. And then he hits it with a lot of electricity. So it's similar to these original experiments that were performed in making these amino acids, and that's can maybe make like a plasmodial amoeba-like life form, which Flubber seems to be.
Although it's also a life form that if you put it on a golf ball, the golf ball bounces higher and higher each time it comes back to the ground.
Yeah, so then it doesn't.
We're getting stretched in opposite directions here, aren't we?
I think they might have had problems with making material claims and also a kids movie, in that it also giggles. And I couldn't work out any way to make a material giggle. And it's also scared of the cold. Like it doesn't like being cold. So there's a bit of sentience there, a bit of movement, and a bit of life.
Some of the Flubber's properties were to do with marketing?
Yeah, definitely.
It's just make it like silly putty and people will flock to the shops after the movie.
And the main thing is, one of its for marketing is that it is like silly putty. So it's a non-Newtonian fluid, which means it doesn't have constant viscosity measurements with speed. So if you move fast, it goes hard, it cracks like silly putty. But if you pull it slow, it becomes a liquid. And so these are we use non-Newtonian fluids all the time, and they're
non-Newtonian, as in Isaac Newton.
Yeah, so it breaks his rules on viscosity. That if you have a solution and you move through it, the viscosity is effectively linear or in some relation that's constant to the speed. So if you go faster, your hand through water, you move it slow, you move it faster, there's like drag there. But in non-Newtonian fluids, that's sort of different. So you can have things that are completely solid with force and then liquid without it.
So I'm guessing that then such fluids, we weren't aware of them back in Sir Isaac Newton's day.
Yeah, exactly. They might have had some, so I don't know how long corn flour has been around, like starch. So the easiest way to make it is you get starch. You might have done it at home, put a bit of water in there, and you make this sort of gooey liquid that if you hold in your hand, just falls out of your hand through your fingers, or if you pick it up and like punch it, it's completely solid.
Okay, that sounds like a really fun thing to do with my son.
Yeah. So there's but all you need, cornstarch and water, and you slowly add the water, and you'll stir it, and you'll feel that you won't be able to stir it anymore because stirring implies the force, which means it makes it hard. But if you stop stirring, it'll turn into liquid.
Incredible.
Yeah, and the way they work is that, and how Flubber would have to work in this sense, because it can do these things, is you need to have long, brushy polymers. And so imagine these polymer chains or like sticks or so. And if they're given, or even spaghetti is a good way to imagine it, given enough time, the spaghetti and the sticks can move past each other. So that's when they're slow, they're liquid. But if you pull on them really quickly, they all sort of grab onto each other. So like the branches of the sticks or stuff. And that makes it solid.
Is that why corn flour, when I've occasionally had it, sticks and other kinds of powder like that stick to the roof of your mouth, and when you try to remove them,
it could
really
be
hard to get them out?
Definitely with corn flour, because in the roof of your mouth it would be getting a bit wet.
They always seem to go
with
there.
Your saliva, and then the sort of surface tension from the top of your mouth is nice and concave. There's little ridges. It probably just sits in there quite happily. And as you're trying, if it's non-Newtonian, as you try and pull it off the top of your mouth, you'll make it stick harder.
But not all powders behave that way, just some.
No, just some. Just if they've got long, brushy polymer chains or cross-links. Is one of the ways you can make flubber at home is you just take PVA glue. So like that's the alcohol, it's a polymer chain. And then you can take borax, which is sodium borohydrate or something. That's toxic, so maybe avoid the borax, but that cross-links it all and makes these slime. If you want to do without the borax, you use stuff like starch. But you can just Google how to make silly putty online, and you can make it at home and make flubber.
And you just leave it. Say you got it in the bowl,
Yeah.
and you don't try and stir it, it'll be pretty reasonably
You can make it so it'll look liquid. If you don't, you can pour it around.
But you try and stir it vigorously. It's hard
It
to
even
do that.
cracks. If you get a big, if you got a big enough bowl with a wooden stirring spoon, if you go hard enough, you'll actually see the solid crack as you try and stir for it. And you have these shards of fluid that then, when you stop pushing on them, turn into liquid. It's like a really interesting. It sort of blows your mind and how a solid can behave like that. And that's why it's non-Newtonian, because it broke all the rules of what we thought fluid should do.
How did that, when we began to realise that these such things existed, how did that change science? Because then we have to set out some new laws to explain that.
It was convenient that they just called it a non-Newtonian. So instead of, all the other rules still existed. So we didn't have to say that fluids don't work anymore. It was more, we've found a new class of fluids that slightly different.
That does seem awfully convenient.
Yeah.
Right.
It would have been worse if we found out that everything was non-Newtonian and then the laws of physics were wrong.
Was there a panic? And people thought, oh my goodness.
I don't think so, because I think all of our stuff on fluid dynamics was working. We know what happens if you have a cup of water. You can drink out of it. It all makes sense. And then someone came along with a new material and was like, this doesn't make sense. I don't think anyone went back and was like, maybe my water's wrong. So it's kind of the nice bit of making a new material. It can have its own properties, but it doesn't really change the laws of physics. I mean, non-Newtonian fluids still obey the laws of physics. It's just not what we expected when Newton was around looking at fluids.
And that's because of the nature of the polymers. And what happens when they basically, if you apply force, they get in each other's way.
Yeah. If anyone has any time to go onto YouTube and look at non-Newtonian fluids on a speaker, that's really interesting because it vibrates, and the vibration causes it to solidify, but then when it sort of relaxes, it goes solution. So you have these weird vibrating on and off, and it actually makes it grow into these weird snakes that grow up and build on top of each other.
I think I saw something the other day which was quite mesmerising, and it probably changes depending on the music you're playing.
Yeah. So you can have different frequencies cause it to grow at different rates or do different things, and it's just like these little worms growing.
Apart from these things that kind of confound our sense of the everyday, is a flubber-like substance or a non-Newtonian fluid, if we go down that road, useful in other ways? Do we use it?
So they use, I know that they use non-Newtonian fluids as shock absorbers in like shoes and things, because it's kind of like you apply force and it hardens up, but then it's soft when you're not applying force. But I don't know if there's any real big sort of game-changing ideas out there that need them. If flubber could do one of the things, what flubber is called flying rubber. That's where it gets its name. And so it can fly as well. And that would be a game changer, because in the movie he makes a car that flies out of flubber. And that would change all of...
Now, why does it fly?
So what they do is they take seaborgium, which is element 106. It's only ever been made for a couple of seconds just to prove we could. For some reason, they decided that was the element they were going to have a box of. And they use it as a gamma emitter. It's actually an alpha emitter, so it emits small helium atoms or nucleus, so 2 protons, 2 neutrons. But they take the cyborgium and they hit the flubber, and because it's in the promo, you heard it say a metastable compound. So that means...
Actually, what does metastable mean?
So it means it's stable, but it has high potential energy. So it's stable within a certain materials frame. So you can have something that's stable and you heat it up and then it falls off. And so the best way to think about it is a ball on top of a hill in a little well. It's sitting up there quite happy, right? That's metastable. But there's so much energy that if I push the ball a centimetre to the left and it rolls down a big hill, that's how it releases its energy. So the idea of flubber is metastable is this ball on the hill. And you hit it with radiation and it releases all this energy.
Yeah. And it doesn't take much.
No.
Suddenly you've got a whole lot of action.
Yeah, that's the idea. And so then it goes back to, does flubber have infinite energy or is it absorbing its energy? So it's hard to know. But the way it flies is then breaks another law.
Yeah, I thought it might.
So they have a container and the flubber's bouncing in the container. And the idea is when it's bouncing, it's pushing the container upwards. And that breaks Newton's law of motion. For every force, there's a recurring force. So it's the idea you can't have if you have a boat with a fan trying to push the sailboat, you can never get that to work because the fan's pushing the sail, but it's also pushing the boat backwards. So
really?
That's
so that's why if you blow on a sailing boat,
It won't
you know
do
those
anything.
scenes?
Yeah.
It's just going to, the opposite action will cancel that out.
Yeah. And so they're trying to basically, that's what they're saying happens. And so that doesn't really work. But there is this new drive made by, it's called the EM drive, electromagnetic drive, made by NASA. And they put microwaves into a sealed container and it produces force. And they're not quite sure how that works. It might be something to do with the vacuum, some like quantum vacuum. They think it might also be that maybe the microwaves, as they're going forward, are heavier than when they're going back. Because everything's going at the speed of light, it's breaking all these rules of physics. We're not quite sure. But if flubber could somehow bounce, and if it's sentient, control when it releases that energy, on an every up have more energy than every down, somehow through like the magics of flubber,
It could lift a car up.
That could lift a car. But it's based on it having infinite energy and a sentient ability to release that energy.
Yeah, it's the sentient stuff, really, that kind of, unless you believe, I don't know, that God's in everything.
Yeah.
In which case, of course it would.
Yeah.
Otherwise, it doesn't seem to me like we really pass the test.
No,
if
not
we are,
for
if we're
being
applying
able
a
to
test
fly.
that there's anything that comes close to what flubber does.
Yeah. The only
in
thing that
movie.
comes close is just the actual marketable, consumable toy flubber, like Silly Putty. And that's why they made it. And if we've still got time, I actually have a fun story about when they first did that. So after 1961, the absent-minded professor came out and there's a big flubber thing. So Hasbro started selling this compound called flubber. It was made of rubber and mineral oil, but it's what the Silly Putty, and they said it was non-toxic, it was really good. Turns out some people's hair follicles were allergic to this and it started making their hair fall out. So they had to recall all this product and they didn't know what to do with it, so they tried to work out how to get rid of it. So they first tried burning it. It was near Providence in
Rhode Island,
Rhode
the United
Island,
States,
yeah.
yep.
And they complained of like thousands of like tons of black smoke coming out. So like, okay, we can't burn it. So they decided to just put it in the dump. So they put it in the dump, and then all the kids started breaking into the dump because they knew there was thousands of flubber balls there, and so they couldn't leave it in the dump, and they got permission to sink it off the coast, but all the flubber was floating. And so the Coast Guard ended up getting, I think, 50,000 flubber balls from the ocean that they recovered, gave them back to Hasbro. And the thing they finally did is they buried it under the ground in a car park next to their factory. And they're like, cool, it's all done, easy, good riddance. But then there was some change in like the water table or something happened underground, and the flubber started coming up through the cracks in the concrete. And this was sort of just after, the year before they released the new flubber with Robin Williams. So that might have been a little kickstart to the flubber business again when they realised they had 100,000 flubber balls under the ground coming up.
It's almost like plutonium in that you've got to bury it and it keeps on coming back at you.
Yeah.
You don't bury it really well. Did you have flubber as a child, Nate?
I had Silly Putty and I had the flubber, I remember the flubber Happy Meal toys. So it was big enough to have Happy Meal toys. We had them. And the Silly Putty was one of my favourite toys. You pull it, it snaps. You can pull it slowly. You can get newspaper and do the imprints of the flubber. You put the flubber down onto the newspaper, and when you pull it up, you can see whatever was on the newspaper. So really fun toy.
Formative one, would you say?
I think so. It definitely got me interested in, I guess, chemistry and things. The corn flour and water non-Newtonian sort of flubber, that definitely was formative. That was like a first time you actually get to play with like an experiment as a kid, and it doesn't behave like you think it should.
What are you specialising in now?
So I'm a solar energy researcher. So I make things similar. So I make organic molecules and nanocrystals to make new types of solar panels and LEDs. So it's optoelectronics, interactions of light and energy is what I work with.
Well, if you ever crack that one in terms of getting more energy out of the sun than it's sending down to Earth, then you'd be a wealthy man.
Yeah, exactly.
But we do have to rewrite the laws of physics.
Yeah. Or if I can invent Flubber, I'd also be wealthy. That's what he does in the movie. He saves his university by inventing a new energy source. So that would be great as well.
Thanks for listening to this episode of Sci-Fi Sci-Fact, hosted by me, Brian Crump, produced by Andrew Robertson, and of course, made possible thanks to the incredible knowledge of those brilliant scientists at the MacDiarmid Institute. You can find more episodes of Sci-Fi Sci-Fact on the RNZ podcast page. RNZ podcasts are also available on Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or pretty much wherever you might find your podcasts. And make sure to follow us so you don't miss out on any new episodes.